The laws of physics affect everything in the world around us. One great example of the laws of physics in action is a Formula One car. These machines are highly tuned and engineered to take advantage of the rules of physics. Today, I will talk about three examples of the concepts of physics that affect Formula One cars. First, I'll talk about how friction allows the car to move on the asphalt. Then, I'll explain the conservation of energy through the car's ERS system. And finally, I'll explain the G forces that the drivers encounter through a corner and on the straights. First of all, tires experience friction, or the opposing force of motion between two surfaces. They take advantage of static friction, or friction that prevents an object from sliding. This allows the tires of the car to transfer the power of the engine to the ground without sliding. Normal road tires are designed to grip the road under normal driving conditions, meaning that the driver cannot take corners too fast or accelerate too violently, or the tires will lose grip. Formula One tires are made specifically for racing and are made of a much softer rubber with no grooves. This allows the coefficient of friction to be much higher. A normal road tire has a peak coefficient of about 0.9, whereas a Formula One tire has a coefficient of friction of up to 1.6. This means that the tire can withstand higher cornering forces and more violent acceleration than the road tires. The downside to this is that in the rain, due to there being no grooves in the tire, the coefficient can drop to as low as 0.1, whereas the road tire only drops to about 0.4. The law of conservation of energy states that energy can neither be created or destroyed, only change into a different form. In Formula One cars, there are many places where energy changing forms takes place. Most of this energy is lost in the form of heat, which is the reason that the tires and the brakes heat up. In 2009, the Kinetic Energy Recovery System, or KERS, was introduced. This system was designed to harness the wasted energy from heat caused by braking, turning it into electrical energy that was then used to give the car a boost of up to 80 horsepower. This system has since been updated and is now just known as ERS, or Energy Recovery System. There are now two parts to this system, one similar to KERS, which harnesses the heat of energy from braking. The other system harnesses heat energy from the spent exhaust gases and converts it into electrical energy. Both these systems working together can give the car a boost of up to 160 horsepower. Finally, I'll discuss the G-forces the driver feels during cornering. During cornering, a driver experiences centrifugal force, or the inertia of the driver acting against the turn. This causes the driver's neck to undergo tremendous stress, and as they can sometimes feel up to 6 times the force of gravity during a corner. These same forces affect the driver during acceleration and braking. During acceleration, the driver's body resists the change in velocity and they are pushed into their seat. And during braking, the opposite happens. The driver's body resists the change in velocity and is thrown forward because of their inertia. The only reason they do not fly out of the cockpit under braking is because of their harness. The braking force of a Formula One car has been described as unlike any other vehicle. Some say that hitting the brakes for the first time feels like hitting a brick wall. The braking force of a Formula One car can cause the driver to experience up to 5 Gs under braking. Because the force associated with racing is so great, they often take a toll on the drivers' bodies. This has made it necessary for the drivers to focus on neck strength during their training.
Hamilton leads. Vettel is right behind him. The gap is less than a car length.